Section 6.2, rational exponents. First definition, a to the 1 over n. We're going to let a be a number and let n be an integer such that n is greater than 1, where n is a positive value. So if nth root of a is a real number, then a to the 1 over n is equivalent to the nth root of a. For example 1, it says, convert to the radical form and simplify if possible. So first thing, it says the parentheses of -8 to the 1/3 power. We need to change it to radical notation. So the bottom number is always your index if you have a fraction power. So it's going to be the cube root of -8. Well, what number multiplied 3 times in a row gives you -8? The answer is -2. On B, it says -100 to the 1/2 power. Notice that this negative here is not in parentheses. This means -1 times 100 to the 1/2 power. Because of that, the 100 is giving the index of 2. So we have -1 times the square root of 100. You don't have to write the 2 here. It's already implied that it means the square root. Well, square root of 100 is 10. So you get -1 times 10, -10 as an answer. On C, it says parentheses -100 to the 1/2 power. Again, our index is 2, but notice that the parentheses is protecting that 100. Becomes square root of -100. Even index, negative inside. Does not exist. Not a real. Next definition, a to the m over n. So we're going to let a be a real number and let m and n be positive integers such that m and n share no common factors and n is greater than 1. So if the nth root of a is a real number, then I can write it as a to the m over n equaling, in parentheses, I slid out the numerator value. The m came out, so I have a to the 1 over n raised to the m power, which means the nth root of a to the m power. Or you can write it as a to the m over n equals the parentheses of a to the m. I kept the numerator inside and slid out the denominator, 1 over n, and wrote it as nth root of a to the m. Either way is going to give you the same result. Example 2 says, convert each to radical form and simplify. So it says 8 to the 2/3 power. First thing I'm going to do is I'm going to rewrite it as 8 to the 1/3 power, 2 on the outside. The numerator came out and I left a fraction of 1/3. This then translates into, remember it's 8 to the 1/3 is the cube root of 8 squared still. Well, a number multiplied 3 times in a row gives you 8 as a value of 2, and then square it. 2 squared gives you a result of 4. The next one says 100 to the 5/2 power. Again, rewrite it where you have 100, inside is 1/2 because the denominator is a 2. Outside exponent is a 5. So then we become the square root of 100 to the 5th power. Well, square root of 100, that's 10 raised to the 5th power. So 10 times itself 5 times in a row gives you 1 with 5 zeros, so 100,000. On C, it says 4 to the -3/2 power. First thing I notice, it's a negative exponent. First thing I need to do is write it as a positive. So we're applying the rules from Unit 4 by writing it as 1 over 4 to the 3/2, so the exponent becomes positive. Next thing we'll do is write it as parentheses 4 to the 1/2, 3 on the outside. So we have 1 over the square root of 4 cubed. Well, a number multiplied 3 times, squared, square root of 4 is a 2, and 2 cubed makes it 1/8. On D, it says negative 81 in parentheses to the 3/4 power. So first thing we're going to write it as, I'm going to make bracket use in this one. So I have parentheses negative 81 to the 1/4. Close the bracket, 3 on the outside. The reason I use brackets is because there's parentheses involved already. So now we see the 4th root of negative 81 raised to the 3rd power. The minute we had an even index and a negative inside, does not exist. Not real. Example 3 says, convert each expression to radical notation. So it's in rational exponents right now. We want to convert to radical notation. Remember, the denominator is your index. So this becomes the 5th root of a to the 3rd, or you can write it as the parentheses 5th root of a to the 3 on the outside. Either or is correct. On the next one, notice the parentheses are protecting the entire thing. Parentheses are around the 5x squared, raised to the 1/3 power. Because it's protected, it needs to make sure that the entire thing goes in the radical. So it's cube root of 5x squared. They're joined inside. On C, it's different. C says 3y to the 1/4. There is no parentheses. This is actually saying 3 times y to the 1/4 power. The y is the only one that has the power value. So it becomes 3 times the 4th root of y. So 3 4th root of y. Example 4 says, convert each expression to an equivalent expression using rational exponents. So they gave us the 4th root of b to the 3rd. So remember, this is your index. The 4 is your index, which means that is your denominator. So I'm going to write b to the 3/4 power as my conversion. On B, it says radical 7a. Notice that 7a is together inside the radical, and there is no index given to you. Remember, when it's talking about square root, we have an imaginary little 2. So when 7a escapes, you don't write it as 7a to the 1/2. You have to use parentheses because the 7a are joined together. If you look at C, B and C look similar. Difference is 7 is inside the radical, 7 is outside the radical. On C, we're actually seeing 7 times the square root of A. A is the only piece being affected by the radical, so we become 7a to the 1/2. Example 5, it says, use properties of exponents previously introduced in 4.1 notes to simplify. So the rules of power rule, bases are the same. You add your exponents if they're being multiplied. If bases are the same and you're in division mode, you subtract your exponents. So on A, it says y to the 2/5, y to the 3/5. Bases are the same. We add our exponents. So we become y to the 2/5 plus 3/5. So we become y to the 5/5 because 2 plus 3 bit denominators are the same. So we can add our exponents. 5 over 5, which reduces to 1, so our answer is y. On B, we have a negative exponent. So the first thing I'm going to do is I need to move something. So I'm going to move the entire a to the 1/2, negative 1/2, down to the denominator. So we become 6 over a to the 3/2, a to the 1/2. The reason I did this is because now I see that my bases are the same, so I can add my exponents. So we have 6 over a to the 3/2 plus 1/2. Denominators are the same, so 3 plus 1 is 4. So we have 6 over a to the 4/2. Well, 4 divided by 2 is a 2, so we result in 6 over a squared. On C, when we look at the thing, we have parentheses of s to the 1/2, t to the 1/3 divided by w to the 3/4, all raised to the 4th power. This is known as our power of a power rule because there's more than one power inside. Power of power means that exponent on the outside is being multiplied to each individual part. So you're going to break it up into individual pieces. So we're going to become s to the 1/2 times 4 over 1, t to the 1/3 times 4 over 1. The reason I'm making it as an improper is because we're multiplying times fractions. Over w 3/4 times 4 over 1. So 2 goes into 4 twice, so we get an s squared. 3 cannot go into 4, so you're left with t to the 4 over 3. 4 and 4 cancel, leaving you with w cubed.